Hi there, welcome back to this channel. In this video, I'm going to take you through Maxima and Minima of functions. In our previous lessons, we've gone through the different types of functions. So we continue from the Maxima and Minima of functions. So under this, we're going to look at local or relative minima or maxima, then as well as global and absolute, minima or maxima. So if this is the first time you have been on this channel, comment, subscribe, and please watch this video to the end so you understand every part of the video. So first of all, when we say local and when you say global, you know that when you say local is something like confined towards your neighborhood, right? Neighborhood. Then when you say global, it looks like something international, right? Something like international. Or you say that's overall. So considering minima or maxima, we are talking about the minimum or the maximum point. So when you talk about local minima or local minimum, we mean that among your neighborhood, you are the least, right? You are the minimum point among your neighborhood. But global means that among the entire domain, So entire domain. So among the entire domain, you are either the minimum or the maximum, right? So from this diagram here, let me illustrate it to you. So first of all, let me start with one local minimum. So when you say local minimum, a point is said to be the local minimum, right? So you have the local minimum at certain point. Okay, so a point will have a local minimum at, let's say, x naught. If f of x naught is less than or equal to f of x, where x is the neighborhood of x naught. So let me put it this way. So if you have your local minimum at point x naught, right, then what you are trying to say is if you take the functional value of this x naught, it should give you a value which is less than or equal to the functional value of any arbitrary x, where this x here is all x in the neighborhood all x in the neighborhood of x naught. Okay, so we treated neighborhood in our previous lessons. So when you take any points in the xy plane, the points, let's say, which you have taken from the x-axis here, this coordinate here will have neighborhood. So the immediate set of numbers on the left or right side of, so assuming you choose a point here, the immediate set of numbers at the left and right of this particular coordinate here becomes what your neighborhood, right? So it's like something surrounding you. Okay, so the local minimum is saying that local minimum may occur at a certain point, say x naught, provided that when you take the functional value of this x naught, it is always less than or equal to the functional value of any arbitrary x, where x is found in the neighborhood of what x naught. So from this diagram, when you are talking about local minimum, you know that for the minimum value of a function, it's always go this way. You get it, the least value, right? Whilst this goes for the maximum value. Okay, so from here you realize that this is a minimum point, this is also a minimum point, right? But when you take this minimum point here, it happens to be minimum only over from here. It happens to be a minimum point only from what, here to this side, right? So for this set of points here, when I take this point happens to be give us the smallest, functional value, right? So within its neighborhood or within its local, it happens to be the smallest, right? But for the entire domain, which is from coming from your negative infinity to your positive infinity, it is not the minimum point. Okay, for the entire domain, it is not the minimum point, but for just its neighborhood or around its region, it happens to be the what, smallest point here. Okay, so that is minimum local minimum. So when I say global when I say global minimum, then so for global minimum, for a point to have a global minimum at a certain for a point to have a global minimum at a certain point x naught, then f of x naught should be less than or equal to f of x, right? Should be less than or equal to f of x for all x in the domain, for all x in the domain of f, in the domain of f. So what this is trying to say is, for global minimum, it should be the smallest point, it should be the smallest functional value, okay, over all the odds, the others, right? So meaning if it's occurring at this point, meaning that when you take the functional value of that particular point, or when the functional value of this point happens to be the least on the entire domain, okay, so this happens to be like maybe you are the best in Ghana, but for the overall in the whole world you are not the best, right? So whenever you have quadratic curve or cubic functions, you see at this point the turning points, these are what, the peaks. Okay, these are the peaks. So the peaks can either be a maximum or what, a minimum, right? And for it being a minimum, it can also be a local minimum or what, a global minimum, right? So this is a minimum section of our curve here, but this is also another minimum, and you realize that this one steps very down, making it the global minimum, this being the local minimum. So this is only a local minimum because the functional value here, or the point here, is smallest among only its neighborhood, right? And not for the entire domain. So let's see the maximum side. So for the maximum side, obviously you have the local maximum, right? Local maximum. So for local maximum, for this one, the points f of x. So if you say that a function has a local maximum at the point x naught, then it means that f of x, right, is always greater than or equal to what, f of x naught, where x, right, for all x in the neighborhood, for all x in the neighborhood of x naught. So for this one, we're trying to say that if you find a functional value of x naught, let me do it this way. If you find the functional value of x naught, it should always be greater than or equal to the functional value of an arbitrary x, where x is in the neighborhood of what, x naught. So when I come to my graph here, I have only one peak here, right? So the peaks are here. The peaks are here. So with this peak, I'm going to have with this peak, I'm going to have the point arising here is only a peak among its neighborhood. So What I'm trying to say is when you have the rising peaks, okay, you realize that what's the highest and what's the what minimum peak, okay, what's the highest and what's the what minimum peak. So this one is a local maximum. This is because among its neighborhood, right? When you take the functional values of what, so this is, let's say, our x naught. So when you take its neighborhoods, it happens to be the point that gives the maximum for the functional value, right? So meaning at this point we get our local maximum. But remember, let's go to global maximum. So for global maximum is the same as the condition I've just given, which is f of x is always less than or equal to f of what, x naught, right? But here is in all, where x is what, for all x in the domain of f, right? So for the global maximum, we are going to consider for the entire domain of what, f, right? The point x that is going to give what, the highest functional value, okay? So in this plane, realize that this is a local maximum, this is local. Where will be our global maximum? Which point is giving us the highest peak, right? You realize that there are certain points which are giving what values at this. So approaching infinity, right? Approaching infinity. So having a value approaching infinity, we will say that, let's say, this or this will be our what? Global maximum. Global maximum. But let's see, a point can be both. So let me give you these key takeaways. So one, a point can be both global and what? Local minimum or maximum, right? So sometimes this point, if you have, you can have a graph where, let's say, you have only one steep downwards, right? So for this one, the point here will be both the local and what, the global minimum, right? So it's possible to have a point to be a local at the same time a global minimum. So in summary, just picture local and global in our real life situations as you being in your country and you being the best in the whole world, right? So among your peers, you are the one who is outstanding, or you are having special qualities, or you are maybe doing something special. But when you come to the whole world, you are not the one. And it can happen that within your neighborhood, you are the best, but as well as what, the whole world, right? So thank you for watching this video. Please don't forget to like and share.